All right, before I begin, are there any questions, any problems that you would like me to do?
The last problem we did at the end of last class.
All right.
I don't remember that one.
I can pull it up easy enough. Let me pull up the OneNote and it'll be in the last thing we did. This one right here? Okay. This is when we were doing the weirder, the more exotic examples.
I kind of understood it, but I messed up like I think 2 steps.
Okay, do you want me to redo it? All right, let's grab this one right here. Yeah, whenever you see a power to the negative exponent, you have to, well, you don't have to change it, but almost certainly you're going to want to, especially with these problems are asking you to write everything with a positive exponent.
All right, so there we go. First of all, I guess there's maybe 100 ways to do these things. Probably not that many, but there's several ways of doing all of these. My goal here was to make everything have a positive exponent first. So let's do that. I'll pause there. Do you agree with that? Yeah. All right. Now you got to do the parentheses before you do anything else, correct? Right. So in there, inside of there, I have division and then multiplication. Which would you do first? Why? Does it come second? If you were going from left to right, which one is first? That thing, that thing. That's first. Oh, should these on the same thing. Sorry, so that's one thing is you do whichever comes first. So I need to append to this before I do that. Yeah. All right. So how do you do that? Divide by 4 part. Well, one thing you might consider is to rewrite it as 401. That way it's compatible with this division. Why would you change to H2/1? It's already a fraction, isn't it? Yeah. So I just made that into a fraction so that this next step is where you flip the fraction. You change it to multiplication. That was from like our first week of class. Well, now everything's multiplication, which is nice. You can now just multiply straight across. And you're going to get what all we're going to end up getting here. 1 over, I'm going to have a 4, h squared, and k squared. You got this? Do I multiply it? What do you mean? I'm not done. You're not done. I have to take everything to the second power yet. But inside is done. My four. Where I just rearranged it so the number came first. Now, let me move it up, and I'll take everything to the second. So we're gonna have 1 to the second power, all over 4 to the second power, h will be to the fourth power, a to the fourth power. I took everything I squared everything. 1 squared is just 1. And all I'll do is evaluate the 4 squared when I write my final answer. Yeah, that's not what you want to have. Just kind of saw it. Actually, if you left it 4 squared, it wouldn't bother me, but I have a feeling the book would require, when you go in and write the answers for your homework, they'll almost certainly make you put 16 there. Yeah, it's how you simplify further. Good. Other questions? Follow me. Give them an indication where I'm at in this class. I don't know how this camera helps anybody. I think I've got everything. You haven't started, oh, well, then I guess we'll. Other questions? Anybody online want have some questions?
Nope.
Okay, good. All right, well, today will be the last day of material. We are going to do 2.3 and 2.4. Let me put up. I have an overhead for this. I don't know if I can. But if you have the syllabus handy, maybe I'll pull it up. Yeah, that's a good idea. I'll pull it up. Pop into here. Next one's his test, and then the Wednesday after that will be the final exam. Sorry. We've got 336 hours left. Where are we at anyways here? Let's go into, the syllabus did not get harmed very much this semester. I think I had to miss a day because I had a cough, or we had, no, what was it? We had computer issues. That's right. They always seem to get me at least once for something. All right, anyways. So what happened then is I had to make everything, fix it up right here. See this stuff? We're Xing that out. We're not doing it. That's correct. We are going to end on here. Yes, you'll have to. Look, they'll start in that section most likely when you go to the next class anyways. But this right here is where we're going to end. The quotient rule, this is the monster. Right here, if you think this is where the absolute pinnacle of all those rules are going to come into play. There'll be like hundreds of rules for each problem. No, not that many, but they're like 10 rules. So 2.3 is the big one. 2.4 will feel like, it's so nice after that horrible 2.3. All right, so with that in mind, I think what I'll do for 2.3, it's not really more material, although there's 1 or 2 things that they do tell you about. It's different. Where was it going to go? Oh, yeah, probably Alex. Pull up the book. Yeah, it's going to introduce a new rule. I'll show you in a minute.
let's go here. Because we have a slew of homework. We're gonna do, I can't imagine how many problems we're gonna do altogether. 2.3, the quotient rule. There really is one rule, but then they exploit it to death. Well, yes, essentially, yes. Let's see.
It's like the.
I do not know about, but I will take your word on it that it is. I've often heard that music and math are very related. And I'm not a musician, so I don't know. Let's pop here for, actually, I did this, this is today's stuff, right? Yeah, okay. All right, then. As usual, we'll start kind of low and then we'll go from there. Let's examine this thing here. That stuff's all well and good and everything, but here we got 2 to the 4, 2 to the negative 4. Now, if I wanted to evaluate, usually when you evaluate these things, you're going to use your calculator and you don't want to have the negative exponent. So we would like, it's much simpler if they're in positive exponents, at least for you to do by hand. See if you agree with that. Okay, I just used, I don't remember what a negative exponent was, I think it's what it's called. Yeah, you remember the names of the rules. I just know how to use them, yeah. It's kind of like asking somebody who lives in the town how to get somewhere but they don't know any of the streets. It's a the right left. I don't do, I know some. What would you do at this stage though? Just use our regular rules. What, how do you perform a division like this? You change it to 2 to the 3 over 1, don't you? Yeah. Now, the rule for multiplication, I don't think it's probably that bad to remind everybody that if you have B and you're doing times C over B, the rule is that you multiply across, that's what I've heard students call it. All right, now I have everything in positive exponents. I can multiply across and I get 2 to the 3rd divided by 2 to the 4th. And what do you end up getting if you do this problem? You say 64. 64. That is not true. At the top, I don't want to actually go to numbers, but we can. 8 over 16 is equal to 1/2.
Put it in a bracket.
So what did we have? We had 1 over 2 to the 4th divided by 1 over 2. That was ended up being 2 to the 3rd divided by 2 to the 4th. Now check this out.
Yeah, that's literally what I was gonna say off there.
According to the rule of exponents, we can break this up in the following. Well, actually, let me be really specific up here. All this stuff is in the exponent, okay? Well,
I know it will be, but look this. This will end up being, 2 to the 3 times 2 to the -4, won't it? Which equals 2 to the 3 divided by 2 to the 4. Which is identically what we got over there. So the rule that I'm gonna wanna look at is this exact thing up here. What happens when you have an exponent like that? We have to do that kind of stuff. That's the quotient rule. Oh, I don't think I finished this thing, did I? Another piece of the quotient rule. I know you want to go, that's 8/16, but check this out. Can't you do this? If I take out, let me write it this way. Would you agree that's true? That I can wipe out 2 to the 3rd on the top and the bottom, can't I? Well, there's a 1 over here. There's still a 1 on top, maybe. This is the nature of what we're going to be doing here. Now, at the beginning of all of this is all sort of jumbled, but when I did this at the beginning, so on the one hand, we wrote that. On the other hand, isn't it true that 2 to the -1 is equal to 1/2? So I wrote the answer in 2 different looking ways, but they're the same way. So there it is. Let me write the exponent rule up and then we'll do 5 or 6 trillion problems. So this rule looks like if I have a to the m minus n, in case I forget it. That equals a to the m divided by a to the n. So let's put a box around that. And let me show you why that even works. Being the math teacher, I have to show you why it works. Look what I'm doing. You recognize that I'm doing identically what I did with the numbers? Accordingly, I can break this up as a to the m times a to the -n. And then we can use our rule that rewrites a to the -n as 1 over a to the n. And so if you think of this a to the m as being over 1, here you get the result. All right, all the rules, unless I say otherwise, tell you to simplify these things. So try to simplify that. Use the technique I just used. And whenever you're dealing with these exponents like this, when they say simplify, they want you to get positive exponents for your answer. So for this, what do you get when you simplify it? z to the fourth power, because you can rewrite this as z to the 11 minus 7, correct? That'll be z to the fourth power. Exactly right.
Is there any problems with this? This is obviously the easiest one. It technically, they're all power rules. I mean, they all involve exponents. Let's look up something a little more complex looking then and see how you do with it. Put it over here. I think if I make them too big, they get unwieldy looking. Anybody think they got it? 4K to the second, that's exactly right. The 4 didn't have anything to do with the Ks. It has a different base than the other ones. That 4 is not raised to any power.
It's not, it's just a K.
So when you do this, the only thing that matters, notice in the rule says you have to work with the same base. Is 4 a base that is like K? No, it's not. So the 4 is left alone, you're gonna have 4. And then you're gonna have K to the 4th minus 2. This is gonna be 4K squared. This is why we do a bunch of examples, so that you don't confuse yourself and make up rules that you go along. It's easy to do. For a lot of students, I don't know why they do, but this 4 that's in the exponent wants to be attached to the 4 that's out front. Just seems like.
Sometimes 4 to the second power.
All right, I'm gonna give you another. This. Try this one.
See, the reason I write this is because now that 4 in the exponent is attached to the 4. I put parentheses around it. That makes all the difference. Now it's 4 to the 4th, K to the 4th. You understand? I can't do it without the parentheses.
This equals 4 to the 4th power, K to the 4th power, divided by K squared. Now, when you do your simplifying, please do not touch on the 4. This will just be 4 to the 4th times K to the 2nd. And once again, I'm happy with an answer like that, but if your book insists, you're gonna write 256K squared. So note the difference in the answers.
All right, now we're going to get a little more exotic. What do you think? If you go into a scientific field, especially one that requires some heavier duty math, you'll look back on this stuff that you were learning. Yeah, That's so easy compared to what I'm doing now. I wonder how you got through all those growing pains. All right, so the same game here is you want to simplify as far as you can. Only positive exponents should be left. If you kind of find it difficult to start, which I think you're doing. No, those are t's. We have 35 times 6 times. I didn't do anything now except rewrite the problem, giving you a little more space to think. So when we simplify, I can, well, you notice the 35 and 56, you should remember, we took, how do I want to put it? We tacitly assumed that anybody entering this class knew their multiplication tables by heart. So when I see these two numbers, those are multiplication numbers, aren't they? Multiplication table numbers. You ought to know what goes into those things. Between the 35 and the 56, what can cancel out of those things? I don't know if I asked it weird or not. What is, all right, well, what can you cancel? What goes into both 35 and 56? You divide it by something. All I'm asking is what was it? 35 is 5 times 7. So if I divide out by 7, I'll be left with 5. 56 is 8 times 7. If I divide out then 7, I get a 5. That piece handle. Now, the way you work the t's is I can do this. I can simply put up here a -2. If you don't know the multiplication table by now, I know. Fill in that detail, those details. So we have, in the top, what do we have left up there? 5 t split power. I can simply sneak the 8 under here. So that's why when the math gets so messy, people do tend to conflate rules together, and it causes all sorts of mayhem. All right, well, let me give you one. Usually they have 2 of them that are very similar. So let me give you one just like it and see how you do on it. Not that one. Let's grab 31. All right, same deal, simplify all the way, but then only positive exponents if you can. Yeah, you think you got it?
2/3 C to the fifth.
2/3 C to the, you're actually right. I should write that as both answers are right.
Let me rewrite this answer. Whether it's correctly. I'm not, but I don't know if I want. Strip out, see, both of these are acceptable. Either one of those is okay. I think though, if you use the second version, it's inviting more trouble. Right, and anyways, on the first one, you guys remember we have 20. What do you do something like this, 20 over 30? C to the 11th over C to the 6th? Is that what you're doing?
No, it's just outside.
Well, you can. Now, this should be easy. 20 over 30. When I was a kid, I knew that all you had to divide out was by 10, and you could do this. And the other one, if you cancel that out, you can put it on the side, or an equally correct answer.
So always.
Yeah, exactly. I just wonder what's going to happen as we get more complicated. No, I'm just saying, I don't. You don't last a long time in my game unless you learn to use the things that are helpful and discard the ones that don't help, so I'm trying to see if any of these things, if there's no problem, I don't care. They're certainly right. All right, let's pop into then 34. This is when they're starting to get a little weirder. Same deal. It's always simplify these things until other notice. So otherwise said. Anybody get it? What'd you get?
So.
That's right. There's a couple of ways to do it. Let me show you one way. You're right. 1 over n to the 6th is right. One way to do it is the most straightforward is to do this. M to the 4 minus 10. There's the quotient rule right there. That equals m to the negative 6, but you're told you have to have your exponents positive. So then you change it to a positive one by writing it as 1 over m to the 6th. That's certainly perfectly fine. That's exactly right. This is another thing too. As I taught you, this questioning of your own capabilities just happened. It seems to happen in math more than any other place. You could have done this. Pause there. What do you think about that? It's like it's using the quotient rule, but from the bottom side. I chose to go this way because I would end up with a positive exponent. Wouldn't I? So to me, this is pretty desirable. And I know the other one's perfectly fine as well. One last thing that I want to say, and I don't want you to forget this at any time, is the following. Remember, the top is simply this. Bottom. So if you look at it this way, take out 4 of these guys. I take out 4 of these guys. How many guys are left? 1 over m to the 6. Don't lose sight of that fact.
What they're gonna do to you when you go to higher level math classes, they're gonna start changing the exponents from whole numbers to fractions. Then it gets wild. But that's the next part. That's why, and keeping this in mind, keeping in mind the most basic format, keeping that always in your mind will help you determine if your answer looks weird or not.
All right, so you get the gist there. Here, they're gonna throw some curveballs at you right off the bat here. That thing. Do me a favor, use the quotient rule directly. See if it works. I bet you it does. The quotient rule directly. Go straight to the quotient rule. What does it tell you to do with those exponents? That's right. Not true. But it's related.
But it's,
That's right. 1 over u to the 11th. Exactly right. So let me do, in my mind, there's a few ways of doing it.
And as an instructor trying to teach us, I'm not sure if it's always a good idea to give a single problem. It's obviously going to limit what we can do, but when you show multiple ways, students tend to mix them. So the quotient rule itself tells us to do this. Is that what the quotient? Take the top exponent minus the bottom exponent, correct? So that's equal to u to the negative 11. Which you can write as 4. That's good. Alternate ways. I'm almost like, there's something in my brain that's telling me to stop right this second and don't go a step further, but I'm going to do it. There, you could have done this. That's one way to make them positive, isn't it? And then, if you want a positive exponent, you can always take the smaller, larger minus the bigger. I think you said first. It was related, but not quite in that order. And then one last one, this is actually the quotient rule directly applied in a different way. Could do this. 1 over u to the negative 9 minus negative 1. That's what you get for the answer. All of these would have been valid things. There may even be more than this for all I know. Those are the 3 off the top of my head. So how's this? Pick your favorite. And you know what? Your favorite on some of them doesn't have to always be your favorite. Sometimes the other ones can be. Whichever one comes.
All right, so I think you were able to handle the trick. That was a tricky one. Now let's pop into, no, those are all about the same. Yeah. Now you're talking. You think you got it? What you got? Go ahead and say it off. No,
Is it 2u to the 7th over t to the 4th?
that's right.
What I would probably do, don't lose track of this. I'm gonna cancel the 28 and the 14 and the 28 to be. Two goes in. That leaves a 2. Probably at the most. This might be what most people would do, to try to take out the exponents that are negative first. You follow what I did? For a lot of students too, it doesn't hurt to remind them that the exponent on a single t is t to the first power. And then when you apply your quotient rule, you can do u to the 9 minus 2, those are the u's, and in the denominator, you can go t to the 5th minus 1.
See how I use the quotient rule? And like I said,
There's more than one way to do it. I opted to avoid negative exponents at all. So we end up with 2u to the 7th t
Are there any questions about that one? I have one last problem like it. I think I'll pull it up. It's up to you. We're 2 minutes shy of the break. Do you want to start and finish one and then take a break a few minutes late? Or do you want to break now? If you got to go to the bathroom, you probably want to break right now. You want to get it over with? All right, let's get it over. You want to get it over with? Before the break? All right. We'll just go up to 56. Oh, no, yeah, 56 is what I want. I'm gonna go with 54. I like it better. All right, and then whenever we finish this, we'll take a break from there. No, I'm telling you honestly, not bragging. I am able to do this in my head. I can just simply write the answer. You will too if you practice these enough. It becomes that rote. Vote settled? What'd you think?
Is it A to the eighth over B six to the B, I mean, over six B to the fifth? I got 6 A to the eighth.
No, stop right there. 6 is not on the top. No.
Well, between the 3 and the 18, 3 goes into 18 6 times, right? Why didn't you put the 6 up top when it?
Well, I didn't even write it as a fraction, I just wrote it as like straight up.
So down there, so there goes a 1 up there, but let me rewrite it so I can show more details. Watch what I do. First of all, I'm going to do this. Okay. So I have my 6 down here. Now I'm going to do this. I'll pause there and you tell me if you agree with that. Let's do this then. Let's do this then. 1 is still on top. I can do a to the 2 minus -10. That's the quotient rule, right? Bottom b to the 6th minus -11. Look at the next line. Isn't this relating to that? So we have, let me write it down here, we have 12. 16 and 17. So what I was saying is, I look at the, I can say the answer just by looking at it. And if you practice enough, and you will get enough practice if you go into a scientific endeavor, problems like this pop up all the time, people have to deal with them. So, but if you don't, then this might be the last you have to ever worry about.
I remember doing something like this in physics, and I was like, how do you get negatives in motion?
That's right. Well, yeah. Well, and it's not a negative motion thing either. The exponent being negative just means it's a small number. So it's a little bit different. People think of that negative as somehow being the sign of the thing when it's not.
See, a smaller number to write 2.900.
Well, that's what we're going to do next, actually. It's called scientific notation. So we're going to cover that. Take a 10-minute break. And I'm going to find something on it. The homework assigned. Here. Right, no. Assignments. Oh, man. All right, this is the last section.
I brought this from Revelations in the Bible. Maybe you've seen this, read it before. But as a kid growing up, I got to see stuff like this on Sunday, every Sunday, about demons and things like that. But what's important is look at the big number that they're talking about. In this last, what is it, a book? In the last book, during a final war, 200 million people will be slaughtered in an hour. Now look at what they say, 200 million. So they're writing it as 200 million. Why not do this? Every time instead. And that's 200 million also.
It was kind of loaded to look at.
It's, I don't know if you call it simplified, but to write it every time is a pain. And if you have so many zeros, if you're like me, you have to look at it and go, okay, I'm in the thousands and I'm in the millions. I got to figure out where I'm at. But 200 million tells me where I'm at. So what they did instead is they said this is 200 times 1 million. What do you think? 200 times 1 with 6 zeros. Or, let me do one last thing to it. 200 times 10 raised to the 6th power. I'll pause there. You should have known we get exponents involved in this thing somehow.
You're going somewhere.
And do you agree that 1 million is equal to 10 raised to the 6th power? You guys know that if you take 10 and raise it to a power, the number of zeros is exactly the power you raised it to. Look at 10 to the 6th. How many zeros are there?
10%.
No, 10 to the 7th would be 10 million.
Because you have 7 zeros.
10 to the 8th would be 100 million. So they didn't write it according to, they wrote, whoever wrote the section of the Bible decided to use engineering notation instead of scientific notation before they made this conscious decision. We don't typically write it like this. Our version, it looks like this. This is close though, it's close. I want to introduce scientific notation. Now, the way the Bible wrote, or whoever wrote it, put 200 million, that's typical. If you read a news story, they don't put the long number, do they? But they also don't use this notation at the end, do they? Where do you see that notation that they use at the end? Any scientific paper you'll ever read will have this. Especially if you work in science where numbers are either huge or tiny. So a number like 200 million wouldn't look out of place if we're talking about astronomy.
70-20 today.
That's what they do. What we have is this. Here's the way that they prefer it be written. What we do is we start with our 200 million. Tell me how many zeros are on this number to begin with. So what they do is write it as 2 times 10 raised to the 80th power. That's called scientific notation. Notice it's slightly different than whoever wrote this biblical passage. And scientific notation is not the way you would ever see. They would not write, well, they might. Would they say 200 million? Or would they write 200? They probably would do the 200, I think. Is it a mixture of a number of letter words? But if you look at our debt, does anybody know how 20 trillion? How many zeros are there? what an exciting and positive section this is, isn't it? The debt that I know is 20 trillion. 20 trillion has 12 zeros. If you remember, starting at the end, we got the up to hundreds, then we got thousands, we got millions, billions, and then trillions. I think it's actually worse than 20. Yeah, we use that to work. If you can make this zero, you change it. There's our bet, 22 trillion. Now that, if you were to read it in the newspaper, they would almost certainly say 22 trillion. Now, scientific notation requires this. What we do is we put, I'm gonna make one last change to this, and you're not gonna like it. I'm gonna make number that is now 23 trillion. Why do that? Well, it will be, but I wanted to differentiate the two first numbers, is all I wanted to get at. Now, how many zeros do you see in 23 trillion? There's 12 zeros, but then I want to put the decimal after the 2 but before the 3. And instead of a big dot for multiplication, it's common to use the X symbol. And to write this as 10 to the 13th power. This is better than knowing the number of zeros. That would be 13 zeros, but it also says, take this decimal and move it 13 places to the right. You understand? So if you look up here, if I try to look at this spot right here, which is in between the 2 and the 3, I've got to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places to get the decimal all the way at the end. That's why I have 10 to the 13th power. So instead of thinking of the number of zeros that it adds, keep in track of where the decimal is going. Make sense? Because I don't know who decided this, but no matter what, the format is this. I don't know. 1 digit, then a decimal, and then whatever digits are left over. Okay, let's try some more down.
So trillion,
Say again?
so a trillion is 13.
No, 12.
So
But the fact is 23 has a 13th place now. More than 3. If I just add the 3, this would be 3 times 10 to the 13th. Well, but you're moving 13 places. Let this be the thing that tells you what to do instead, I think, is safer. Decimal, this is 13 places. Let's see, let's try some practice. So you want to write 35 million in scientific notation. So remember, your answer needs to be formatted like this: 3.5 times 10 to a certain power.
yes.
Now count your decimals that you need to move. Right now, if you think about it, this is 35 million point 0, isn't it? Any whole number has the decimal point 0, don't they? I don't know why that's hard to understand. Let's see, number 5 equals 5.0, isn't it? 10 equals 10.0. Number million equals 1,000,000.0. I know, this is why I'm gonna follow this guy. This period means everything in these problems. The decimal is there. How many places do I go to put the decimal there? 7 places, let's count. 1, 2, 3, 4, 5, 6, 7. That's it. Not knowing when the decimal is at the beginning, you can't do it. Let's try. I don't know, in physics, the numbers get kind of huge, but. Let's try, I'm sure your textbook, try the examples, that's way over there.
In fact, do me a favor, to check your answer, simply type that number in long form into your calculator and hit the equals button. I think we got a scientific one on this computer. Just type what you see right there. Oh, I didn't know I'd do that. I got to change my view to scientific. I'm gonna do the same thing. 4, 5, 4. How many zeros did I put on that thing? 15. So I'll do 15 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15 equals. Oh, look at this calculator. It's proving me wrong, isn't it? It just wrote the whole number. It didn't put it in scientific notation. I think they might have it though. It didn't do it. It's interesting. That says it's a scientific notation, but it's not. Ah, there we are. Got it. See what they did? F that whatever that F dash E means. There's my answer. 4.54. That E plus 17, it's trying to tell you that's 10 to the 17th power.
So, do this, where is the decimal initially? Where's the decimal point on the original number? There's the decimal point originally. Now, if I go here and I cruise past all those zeros, there's 15, 16, 17 places before I can get the decimal there, correct? So this is 4.54. 10 to the 17th power. Which is not wrong, but it's not scientific. Well, it is wrong because it's not scientific notation. But your number is still equal to the number I have. It's just the notation that is required is that the decimal be between the first and second digits. That's always how it is. Now look at what the calculator tried to do. I don't know if I can copy this directly. This is what calculators. Are you serious? I didn't mean to click on that. Compare it to their version of the answer. And the E plus is simply because they don't have, I guess they're trying to keep it in one line or something like that, but
you have to understand when your calculator is telling you that it's shifted to scientific notation. And it'll do that automatically on you if you have huge numbers. Say again? Oh, what is it, trillion? Yeah, after, does anybody know what comes after trillion? Quadrillion. What do you think comes after quadrillion? Well, don't think about trillion as trillion. Quadrillion, what do you think comes next? Cinquillion, something of that nature. Well, you get the idea. After that will be sextillion. They stop, after a while, just stop naming. It doesn't, it's easier just to refer to the number than its name. It's kind of like when we're doing, right now we're in gigabyte land, but after gigabyte is what? Picobyte, terabyte? Terabyte is gig, I think. And after a while, it's easier to remember the number of zeros. Now let's switch gears, and I want you to try this. Let's look at small numbers. Scientific notation, the beauty of it is, they call it scientific notation because it has the capability of handling for small numbers. So convert. So this time, follow me. I'm going to start at this decimal. It's easy where the decimal is on these. They're going to put it. In order to get to between digits 1 and 2, how many places did I have to move? So do this. My answer is going to be 1.2 times 10 to a certain power. I know that before I do anything. All I have to do is figure out what that power is for 10. Now it's negative since you're moving the other way. How many spots do we go? 8 places left. So this is 10 raised to the negative 8. You should know, take on your calculator, just type 10 to the negative 8. Small number. To do these. Handles them so simple. And these numbers can get, whoever do take physics, when they start talking about quantum physics, these particles get staggering, small negative. Of course. So I know my answer is gonna look like this, 1.23 times that's the time. It's just popular to use instead of a middle dot, probably because if you have access to, if you're typing this thing out, middle dot may be something that you can't find anywhere. How many places did I move to go from this?
So what we're gonna do for the rest of the section here is a bunch of examples where you get to convert to and from scientific notation. All right, all I want you to do is rewrite these into scientific notation. You can see our numbers. Why are everyday life numbers all of a sudden huge nowadays? I'm not talking about just the data of this country, but look, this is not an unusual hard drive. I have a flash drive that holds that much. How much is that? That's 256 trillion bytes of data, or 256 gigabytes, as you might say. Convert that to scientific notation. So once again, before you start counting any kind of zeros or decimals or anything like, how does your answer, what do you know your answer is going to look like? You know it's going to look like 2.56 times 10 raised to some power. Is that power going to be positive or negative? Positive one. So we know it's going to be positive. So put our decimal, that's because our decimal is over here, and I need it to be in there. So tell me how many places I had to move for that to happen. Was it 11? That is 11 places. But now the direction's different. It's going to the left. So that if we put 11 up there, let me just count to make sure. Right, let me write it exactly. Suppose I happen to own 432 of those things. These flash drives are 256 gigabytes. They're like little, they're treated like plug them in, pull them out. It never even gives you the option to eject. It expects you just to pull in the plug. I've only seen that for 256 and above, not below. So suppose I had 432 such. Well, one way that I could have so many of these is I happen to record music that I listen to on a record to DSD format. I don't know if you guys are familiar with this, but it's a huge numeric format. The MP3s that you're used to using, the sound quality of those versus what I'm doing, the MP3 might be 10 megabytes in size, whereas my same song is a gigabyte in size. So, right, that's right. So I might fill up a flash drive with 256 albums, or maybe 200 albums. Put it aside, buy a new flash drive. Now I've got 432 of these flash drives filled with music. All right, so I have 432 such flash drives. How many bytes do I have available to me?
It's too large.
And if you're right, it sounds phenomenal. You're absolutely correct.
What you got?
1.10592 times 10 to the 14.
That's probably true. 1.10592 times 10 to the 14th is probably correct.
Now, you're doing 256 gigabytes times 432, correct? So I'm doing 432 times 256 trillion. Or you might use, I don't know if you, what version you used in your calculator. Now what I'm gonna do is this. Did I say 2.56 gigabytes? Okay, yeah, gigabytes are billion, sorry. So now watch this. I'm gonna change this 432 to 4.32 10 to the second power. And then I'm multiplying that to 2.56 times 10 to the what? 11? I'm allowed to move things around because multiplication is commutative. So what I could do is do the 4.32 is the 2.56. Tell me, what power of 10 do I have? 13. Because you add those exponents, don't you? Now you are responsible for this relatively small number. That's quite easy to do on a calculator. Your calculator doesn't run out of steam. That number there was 11.0592. It's not quite what your calculator gave you if it did it. Didn't give you that, did it? It did 1.1. So I have to take this decimal and move it one place over there. That means I need to add 1 to that exponent if I want that decimal to be in that spot. We have 1, 1.1052 is 10. Exactly what you said. So, but you see, the scientific notation allows me to work with gargantuan numbers with ease, or teeny tiny numbers with ease. You see, if you try to type these huge or small numbers on your calculator, the calculator will give up eventually, and it immediately will go to scientific notation. It probably did the whole thing in scientific notation, for all I could tell. Speaking of music, I might as well come up with an example. Perhaps you guys know about record store data. Anyways, during these things, some rare records always appear, and they sell for ridiculous amounts of money. So Taylor Swift. Sold for how much money did she make? And put your answer in scientific notation.
Now, keep in mind, this is pocket change for this woman. She probably gave it to her friends, or I don't know. She probably doesn't even like money anymore. It's just too much. Again, I'm able to do this in my head. I'm not bragging when I say I'm trying to encourage you. You can get to that just with some practice. Tell me what you got. Either one, I don't care. 1.699. You got to keep all the decimals. It was 1699, right? Times, not 10 to the fourth. We have, I think, we have 16.9 times 10 to the fourth. This is how many records she sold. And this is how much money she made total. Do you agree with that? That's $16.99 times 10,000, correct? I'm gonna give you a little information about this day. It's a glorious day. I love it. I know they're invited, but then there's a dark side. But this is not the answer that we're looking for. We want this decimal to be in that spot. Remember? So how do I change my exponent if I moved it over that way one place? Changes to a 5 because I made that first piece a little smaller. So in order to compensate, I make the second piece bigger and it stays the same value. This is in dollars, I guess I should say. What happens is of course, I'm combining all these things because I know the crew out. I get to my spot at the beginning of the store, they're going. I go online, I've noticed that England has been selling them for hours now. Why? Well, because they're the start of the day. You know, the day starts. Greenwich, England. That counts as hour 0. England's got the first dibs. So anyways, the English are selling for, in the morning, before I even get to the front, they're selling for $50, $60. I go, well, wait, because I'm going to get mine. So now here's what happens to the $9,250 records. And sell for an average of $175 each. So-called flippers. Everything has a flipper. Houses, record, cars. How much money was made by these flippers? What's that? Well, you know, if you'd had a friend in England, you could do it because then you get them at $17 a piece. They sent them a big bulk for $20 for the whole shipment. And you're good. That's right. Or you could even buy them at $80 a piece from England and then sell them for this the next day, and you're still doing all right. How much do the flippers make? And I want it in scientific notation. This is why Taylor Swift is such a powerful force,
Taylor Swift not only makes herself a billionaire, she makes millions of other people rich as well. She doesn't even know it. I made up 9,250, but most people sold the records. Most people did not actually keep them. I'm assuming a small portion actually were kept. If I straight up multiply out the numbers, here's what I did. You guys get this? So Taylor Swift made a tenth of, so here's a fraction of what these flippers have made. Now, if I want it in scientific notation, where now is the decimal? No, the decimal right now is in front of 5. Right would be behind, right? Okay, how many places does it have to go to get in the correct location? Six places, right? So the way you write it, technically, you're supposed to keep all the decimals, but to be honest, most people would probably stop here and then just write the rest, but I don't need the 0. Six then. Hold on just a second. I've got some extra digits or something. 1618.
If you want it to be once. and then
Yes, thank you. I'm not counting my digits are not working out. We erase one of these 1.6, this guy right here. So she doesn't know it, but she made a lot of people a lot of money. And why I do have some records for say. It's like the long game. Yeah, that's exactly right. Play the long game. That's when my kids are going to want all their money, so I'm going to need it. All right, that's it for the course. That's it for the course. So Monday we'll have a review. I don't know, not many people show up. It depends on what the weather's like, how many people actually come to class. But if I come here and there's nobody here, I'll just run the class from my office. And we'll do, but we're gonna do review for the exam. So the rest of the course looks like this. Monday is review for the next exam. Let me write this stuff up so everybody has it. So Monday, that will be. Sure, I have exam 4 in there. It should be pretty similar to what we're gonna do. I'll probably grab one of the old tests. Then on 5-4, we have exam 4. 5-9. Keep this in mind. During finals week, there's technically no classes. Classes are out. That means I actually am not supposed to be doing it, but I always do. So I always call this, if you look in the syllabus, it says optional review for the final or something like that. Whatever. This day will be used as a review for the final. Same thing as usual. Okay. Like I said, if somebody shows up on Monday, then I'll just have class in here, no big deal. If nobody shows up in here, I'll, the only weird thing about it is, if you're 5 minutes late, I'm going to my office. I can't keep coming back down. So then our last day for good would be Wednesday. I guess it would be 5/11. Check the dates, would you? That is the final exam. I promise you, if you can improve LVP, if you improve a test score, that new thing that you do on the final will erase your old test score. If you improve. Final have 4 parts corresponding to each of the tests. Mind you again, on the review day. But I did that when I got a little encouragement when I saw people did better on the second test than the first test. Lost tons. This has been a horrible semester for schooling in general. So I look for any hope that I can find. Anyways, that's all I have. I guess I will see you one way or another on Monday.
Let me close these people out.